Hey guys, it's Mrs. Golding. I wanted to walk you through your e-learning assignment for February 24th. So your screen looks a little different than mine, but the assignment is called Factoring GCF for e-learning. And the skills that we're going to do, there's 4 skills. We have greatest common factor. There's, let me go back. 5 problems there. 5 problems in this greatest common factor level 1. Level 2, there's 5. And here, there is some with the variable only. I'm going to, since we're not at school and you probably left your notebook there, I'm going to, so what I'll do is I'll replace notebook 20, what are we on, 26, with this assignment so that you can be sure to get it done. So it's basically the same things that we were talking about in class, but you can do it digitally. Okay, so remember there's always these help videos that are embedded in every question, so please use them. The first section is just called greatest common factor. This is back to 6th grade, where you just find the number that these are divisible by, the largest number they're divisible by. So if you're totally stumped on that concept, and if you're not, you want to fast forward because this is boring. But if you're stumped on that concept, one thing that we discussed in 6th grade was one of them is using this ladder method. There's other methods, but so let's say a 2. They're all even, so a 2 goes in there. This would be 2 times 18 to get 36, 2 times 6, and 2 times 12. Do you see that these are still even? So you could go 9, and then 3, and then 6. And then these guys all have a common factor of 3. So 3 times 3 is 9, 3 times 1, and 3 times 2. So this is where I stop because they don't have any other factors in common greater than 1. So then I take these right here and I multiply them all together. 3 times 2 is 6, times 2 is 12. So I know it doesn't always work out that way, that it's one of the numbers, but in this case, my answer is 12. That's the largest number that goes into all of them. And maybe you don't even need all that. You just know it. You can just tell. And the thing that makes it easier as you go is just knowing your multiplication facts and things like that. Makes it a lot easier. Okay, so mouse pointer. Let me move this up here for myself. Okay. I'm gonna clear the screen. Okay, so let's go to a new problem. Actually, I'm going to go to a new section because I don't think you need any more videos on that. Okay, so now we're going to get more into what we are doing in class. So let's go here. So it says factor the expression completely. So like we said, this is simplified form, right? They don't have any like terms. You can't combine them per se, but we can factor them. So we're going to look for the greatest common factor between this term and this term. So is it a 10? Is there anything else that goes into both of them? Let's see. 30, no, 30. Well, it's real easy to tell once you do it. So let's let me get my pen here. Let's say that the greatest common factor is 10. Remember, we kind of pull that out, and then we are going to multiply that by the expression that's left when I factor that out. So 10 factored out of a 60 leaves me a 6, because 10 times 6 would give me 60, plus 7. And then I have this x. I cannot get rid of it, right? It's still there. So then you check yourself. 10 times 6 is 60, and 10 times 7x is a positive 70x. So if it comes back to where you were coming from, then you're good. So let's go here. Clear screen, back. Choop. 10 times the quantity 6 plus 7x is my answer. right. Good. We're good to go. Let's do another one of those. So 9 goes into 63 7 times, right? So really the common factor that they have, the greatest, because they have a 3 in common, but the greatest common factor would be a 9 times the quantity 7x minus 1. So don't forget that 1. So if I distributed, so this is like undistributing is another way of talking about factoring. Some people think about it like that. 9 times 7x is 63x minus 9. It's back there. So we're good to go. I noticed yesterday a lot of you picked this up pretty quickly. So it's definitely easier if you're strong in your multiplication facts. If that's a weakness for you, this might be a little bit harder, but not impossible. Okay. Yes, we're good to go. Okay, so hopefully that part is good. Remember, there's more help videos if you need them. So let me skedaddle to the next section. Sorry, let me get this. Boom. Okay. Greatest common factor level 2. Okay, the only difference here is we're adding some exponents. This is what we did in class. So now you're looking, what do they have in common? And so when I'm saying that, I'm looking at this term and this term. Remember, this is a binomial. There's 2 terms separated by subtraction. So the only thing they have in common, they don't have any coefficients except for 1, right? But they have an x in common. So I'm going to pull out that x times the quantity -3. And then if I am kind of pulling that out, if I'm, another way of saying it is dividing by x, then I'm left with x squared, right? Here, minus 1. So let's look. If I distribute this, this becomes -3x to the 3rd minus x, which is what I wanted to come back to. So my answer would be x times the quantity -3x. And then you can use the caret if you want to. -3 caret, and that's the shift 6 minus 1. Minus 1. Submit that. Yes, I'm sure. Very good. Okay, let's go. Let's do one more of these. I think I only did one of those. So let's hit the new problem. I'm going to go pin, clear the screen. Okay. So let's see. 6 doesn't go into 16. 2 does. 3, 4, 5. 2 and 3. 3 does not go in there. 4 does not go in there. So I think 2 is the greatest common factor, right? So that's of the coefficients. Now let's look at the variables. There's an x squared here. I can divide this by an x squared too, right? Because there's an x squared in there. So we're going to pull out 2x squared. So one way people think about it is it's the, if you find shared variables, you're going to pick the smallest degree, the smallest coefficient that goes with that. That's what they have in common. So 2x squared times the quantity of -8, right? And no x's, right? Minus 3 x squared. Okay, now let me ask you this. Is this also true? What if I factored out a -2x squared? Let's just see what happens. If I did that, this would become a +8, and then it would become plus 3x squared, right? Okay, so later on down the road, it's going to kind of be nice to look for, can I factor out a negative and then have my remaining expression in here be positive? It's helpful. So I'm going to kind of show it that way. So let's go back here and we'll see if the computer will accept this because it It should, because it's also equivalent. These are equivalent expressions. 3x squared. Nope. Squared. What am I doing? Negative 2x squared times the quantity. Thank you. 8. Change your sign. Schooling. Plus 3k. Good. And close your parentheses. Very good. Submit. Okay, cross your fingers. Whoosh, it did. So notice, let me see if it gives that. Yeah, nice. Okay, so it does accept that. Okay, let's go here. I'm going to go back, and I'm going to hit this last section. And the difference in this section from the others is there are no coefficients. There's just variables. So I don't know if that's harder or easier. I don't know. I think it's probably easier, but I cleared my screen. I want to get a pen. Let's change the color. Okay. So again, you're looking, they both have an X and they both have a Y, right? But then look for the smallest exponent that they both share. So of the X's, the smallest exponent would be 4, right? Because this has 4, it has one more. This, they both have 3, and this has 2 more than that, right? So this is technically the greatest common factor of these two terms. So then I'm going to, I don't know. Yeah, I would say it like that. This times 1 would give me that, right? Plus x to the first, or just x, and then y to the second. Okay, so remember, I think I had some of you asked me yesterday, is that whole exponent thing really that important? So here's where it's important, because we're putting it into play, right? So when we're factoring, it's important. So x to the 4th, okay, so that's going to come back to this when I distribute, and then let's see what that becomes. X to the 4th times x to the 1st is just x to the 5th, and then y to the 3rd times y to the 2nd becomes y to the 5th, which is what I was trying to get. So remember, when you multiply like bases, you're going to add those exponents. So the answer to that question yesterday is yes, it is important. So x to the 4th power times y to the 3rd power is the common factor, greatest common factor, times the quantity of 1 plus xy to the 2nd power. All right, let's enter that. What did I do wrong? Can you figure it out? Oh, did I somehow put parentheses around that? Okay. Well, don't do that. If you look where it says, here's the solution, and here's what you said, don't put parentheses around there. Somehow I must have done that. So good to know. Don't do that. I didn't mean to. All right. So go to, I think that this is good, walking you through these. I have a feeling you're going to be pretty successful with these, but I would like you to work on those for e-learning, and I will see you tomorrow. Have a great day.